we have 2 cosine theta minus 1 equals 0. We want to get that cosine theta by itself. So we're going to add 1. So 2 cosine theta equals 1. We'll divide by 2. So cosine of theta equals 1/2. So we're thinking about that unit circle. Where does cosine equal 1/2? Here I've got 1/2 root 3 over 2. And is cosine x or y coordinate? Is x coordinate? That happens. Supposed to be a highlighter there, not marking it out. That happens right here. What is our value for that angle? 30 or pi over 6. So we get pi over 6 or 30 degrees. Whenever you're doing an assignment that goes with this, I want you to try to give both just so you're used to giving both. But on the actual quiz or test, it will. Oh, I've got it backwards. I saw Caitlin make a weird face. Let's back up. I've got that backwards. It's right here. Now it looks better. What is this one? This is pi over 3 or 60 degrees. Okay. I was testing you. Make sure you know what you're doing. Okay. All right. This one is a little bit more difficult. Not really because the problem is more difficult, but tangent makes it a little more difficult because is tangent on the unit circle? No. So we're going to have to think a little harder whenever we get to finding this out. So if I subtract, just like the other ones, I'm just going to subtract that 4. So I've got 4 square root of 3 tangent theta equals -4. I'm going to divide both sides by 4 square root of 3. So I'll get tangent of theta equals, the 4's can cancel here. So I'll get -1 over the square root of 3. And when we're talking about unit circle values, we don't really like to have those square roots in the denominator. So how would I get rid of that square root? Multiply by square root of 3 on top and bottom. So it's negative square root of 3 over 3. All right, so let's think about this a little bit for our unit circle. To think about, let's narrow it down. So you probably do not know tangent right off the top of your head. But we can narrow it down to where we need to look at. First of all, it only asks us to look for principal values. For tangent, where is that at? First and fourth quadrant. So we're not going to look in second or third at all. And I see that tangent is negative. Where is tangent going to be negative? What? Down. Okay, the bottom one, fourth quadrant, right here. The bottom part here, that's where we're going to have negatives. So we got to do sine over cosine to see what tangent is. So we really only got 3 spots to check. What are you going to get when you do negative square root of 2 over 2 divided by square root of 2 over 2? We'll get -1, right? So it's not going to be 7 pi over 4 or negative pi over 4. So we really only need to test 11 pi over 6 and 5 pi over 3, which actually I should be calling that negative pi over 6 and negative pi over 3. So if I look at tangent of negative pi over 6, that's right here on my unit circle. It needs to be sine over cosine, which is the y over the x. So I will have -1/2 divided by square root of 3 over 2. And dividing fractions is easy as pie. Flip the second and multiply. Whenever I do this, negative 1/2 times 2 over 3. The 2's can cancel here because you're multiplying those together. So you get negative 1 over root 3. I actually probably could have left it like that, which is also negative root 3 over 3. So negative pi over 6 does give us the value that we want. If it did not work, then I would pretty much know that negative pi over 3 would be the answer for that one. So our theta is going to be negative pi over 6, or I could call it negative 30 degrees. Now you can memorize those tangent values because they'll always be the same. I don't make students memorize them. If you can figure them out from the unit circle, that's good enough for me. Okay, questions? Okay, let's look at 4. It's a little bit different. Solve for principal values again. I've got tangent theta times sine theta plus 1. And it equals 0. Just remind me, I'm going to give you some. What if I had x times x plus 1 equals 0? That's not how I would solve that. I would not distribute them to solve it. That'd cause you to lose the answer.
You minus the 1? No. I'm really wrong.
What about if I had x plus 2, x minus 3 equals 0? What are the answers there? X equals negative 2, x equals positive 3, right? So here you're doing x equals 0, x plus 1 equals 0, so you get 0 and negative 1, right? We set each factor equal to 0. We can do that same thing even if we have trig functions, right? So if we have two things multiplied, like we see here, we can set each one equal to 0 as long as it equals 0. That's called the zero product property. It only works for 0, right? Because any number times 0 equals 0. But that's not true of other numbers. Any number times 1 does not equal 0 or 1, right? So you can only do this if it equals 0. So I can do tangent of theta equals 0 and sine theta plus 1 equals 0. All right, principal values. We got tangent and we've got sine here. So for tangent, we're looking from negative 90 to positive 90. Where is tangent going to be 0? Yeah, we need to have 0 over 1. That happens at 0, right? Because our sine here is 0 and our cosine is 1. So for this one, theta would just equal 0 degrees or 0 radians. Just get 0 for that. For the second one, we do need to subtract that 1. And then on our unit circle, Summer, where does sine theta equal negative 1 on the unit circle? Okay, right here at negative pi over 2, it's our y coordinate. 3 pi over 2 is what we see, but we got to give a negative value there, so negative pi over 2. Or negative 90 degrees. So you get two answers for this problem. You get 0 and you get negative pi over 2. Like two actually different answers, not just one in radians and one in degrees. Questions? All right, let's look at example 5. We've got cosine squared theta equals 1. What do you guys think about this one? Okay, we can add the 1. And what do we need to do now? We square root to get rid of the square. What's the square root of 1?
1.
Alright. Is this it?
No.
There's something that I'm forgetting. Plus or minus. When you square root both sides, there's got to be a plus or minus. You'll have two answers. So you have one where cosine equals positive 1 and one where cosine equals negative 1. Alright, so what are those, Connor? 0 and pi, or we could do 0 and 180 degrees. Remember, for those, we're looking at 0 to 180, first and second quadrant for cosine. Okay, questions? All right, we got one more that we're going to do together, and then we'll let you guys work on the rest of these yourself. This one's weird. We got sine x minus cosine x equals 0. Any ideas? Okay, so if I move the cosine over to the other side, sine x has to equal cosine x. There's nothing else you can do to solve that problem, but you can tell where that happens on the unit circle, right? So that would happen at pi over 4 or 45 degrees. And since it's principal values, since this one has sine and cosine, if there were something that would give you that in the first or second quadrant, fourth or second quadrant, you would use that. But here they don't have the same signs, so you would give both answers there. We'll see some tomorrow where it doesn't ask for principal values. It is also true that sine equals cosine at 5 pi over 4. But today we're just looking at principal values. So this gives you your assignment. It is similar to what we have been doing. I don't think there's anything much different there. So this will be your homework for tonight. You don't have any homework on the identities, but you can practice some of those if you would like. They're good for practice. I'm not going to require you to turn this homework in until Friday because I'm not going to be here tomorrow to check it. So if you have a really busy night or something and want to hold off and wait till Friday to turn it in, that's fine. I'm not going to check it till then. But please do go ahead and get started on it right now. You got about 12 minutes to try a few of these